Welcome and welcome once again to another exciting lesson. This one is a special lesson, and I call this Outcomes 1 because it's Outcomes 1 from the engineering report that you have to cover. In Outcomes 1, we are answering how to define, investigate, and analyze complex or broadly or well-defined engineering problems. If you have reached this stage, I'm going to ask you to subscribe and hit that ring button in order to get notifications for the upcoming videos of the other outcomes. Now, getting onto the introduction. In order for you to understand the content that I'm going to be covering here, the prerequisite knowledge is lesson 3 and lesson 4. On lesson 3 and lesson 4, I covered TER or TEO. And then in lesson 4, I covered the engineering report or just the introduction of the engineering report. So here I'm expanding, and now I'm going to be covering the outcomes of the engineering report. There are 11 outcomes. So in this lesson, I'll only cover outcomes number 1. Now, I'm going to ask you that you pay attentively or give your whole attention to each and every detail that I'm going to be discussing. In this introduction, I'd like to cover an important aspect, or this is important information, and it's called systems engineering. Now, a lot of people can ask, what is systems engineering? There are others who know already, more especially those who studied BSc and BEng degrees. They would have gotten an introduction to what is systems engineering. To give a brief definition, it's described as a transdisciplinary and integrative approach to enable the successful realization, use, and retirement of engineered systems using systems principle and concept and scientific, technological, and management methods. So already you are getting the feeling that I'm talking about something which is going to help us to solve the problem of defining, integrating engineering problems. Now, let us get onto it. How is this systems engineering applicable to outcomes 1 and the other following outcomes, which is going to be outcomes 2? Now, system engineering is the building blocks of systems life cycle, And what do I mean systems life cycle? I'll take you back. In lesson 3, I debunked the different phases that one can put as your nature of training or experience. I spoke about conceptualization, design and analysis, specification, tendering and adjudication, manufacturing, project, construction management, commission, maintenance, measurements and testing, or planning at complex, broadly, and well-defined level. All these are just the building blocks of the system's life cycle. Now, I'd like to show you some of the models which are used as the framework of the system's lifecycle. I need to mention there are various models that are used in order to tackle system life cycle. But in engineering, the most chosen or used model is the V model. And if you look here carefully, it covers the phases as I've taught you in the other lessons, all the way from concept to release or product phase. And these phases, all of them are required in order for us to realize a system, all the way from not having a system to having a system built and released for use by the user. And you will see you start from requirements, then you analyze them, then you design them, then you will have a engineering type or prototype, as you will say in, and then, you know, it goes in that V model phase where you cover each phase, then you go to the next phase and so on. So this is a well-known model that engineers have been using. And this model is what will help us to answer the questions which are asked in outcomes 1. Outcomes 1 requires us to define, investigate, and analyze engineering problems. That is 1.1, 1.2, and 1.3. Now, what is included in defining, investigating, and analyzing engineering problems? Well, we start by gathering information, then we define requirements, then we prioritize our requirements. We will prioritize it in terms of functional and non-functional requirements. Sorry, I think there's an L missing there. Then we will develop user interface diagrams, which shows how the other functions talk to the other functions. And also we will be showing other things like how the different stakeholders integrate. Then there's, after that, you will evaluate the requirements with the user, of which if they agree with whatever you are presenting to them, you can go ahead and draft concepts. And by so doing, you are almost finishing this phase of the concept phase and preliminary design phase. As you see, it is the beginning of this V model. Now, let me go to the application form. As I've been saying, I'm preferring to use the technologies application form, as it's a good reference for both the engineer and the technician form, as well as the certificated engineer form. Now I'm going to be giving an example, but I will also be explaining how you can make this applicable for your type of work that you are doing, because you didn't necessarily do design work, you didn't necessarily commission, you didn't necessarily manufacture, and you didn't necessarily maintain a plant for the report that you're gonna be using to answer these questions. So let us go and show, using examples, how we can answer those questions.